Plastic is a miracle material. It modernized the world and created endless opportunities for innovation. But the same wondrous material is coming back to deliver a sharp reality. 8 million tons of plastic end up in the oceans every year, killing millions of marine animals and accelerating global warming. And the time estimated for the plastic to degrade? 450 years to never. Plastics are made from natural gas and oil. Both fossil fuels are non-renewable, and experts predict that we will be running out of them in 50 years. So now, humanity is faced with two major problems: the production and disposal of plastics. Bioplastics are solving the first problem of production by using renewable resources such as starch and bacteria. But the most popular bioplastics end up in the oceans just like normal plastics do and don't break down at all. On the other hand, several companies have recently begun to use a special plastic called polyvinyl alcohol that is made from crude oil or natural gas and dissolves in water. This spectacularly solves the second problem of disposability while still falling into the non-renewable problem of conventional plastics. What we see is that there is no current solution in the market that is made from renewable resources and is easy to dispose of. Introducing Positive Plastic, the plastic designed for the future. Fully synthesized from renewable resources, it will be sustainable for decades to come. And when it reaches the landfill or the ocean, it will dissolve completely in water with no toxic byproducts. Here's how it works. Bacteria called Cupria vitis negator are given nutrients for food and they multiply. 90% of the cell body weight is made up of a special bioplastic called polyhydroxybutyrate, but let's just call that PHB. Now this bioplastic by itself is renewable but doesn't dissolve in water. One more ingredient is needed to make that happen. Enter starch, an extremely abundant resource that is made up of chains of glucose and dissolves readily in water. We then graft the PHB to the starch using an enzyme called horseradish peroxidase and hydrogen peroxide. Using this unique, unprecedented combination of polymers, we can create a plastic that is made from renewable resources and dissolves in water. Let's see how positive plastic compares to plastics today. This is a graph showing the offering levels of regular bioplastics and conventional plastics that dissolve in water. Now here comes positive plastic, hitting that sweet spot of features and creating a blue ocean for itself. We achieved two unique goals. First, we created an easily disposable plastic using renewable resources. And second, an important goal is to create a better perception of plastic in consumers' eyes. See, right now, all the policies and movements against conventional plastic have created an anti-plastic mindset. But since we're dependent on plastic in so many ways, it's extremely difficult to get rid of plastic entirely. Changing this negative perception would be a major step to creating a sustainable world with next generation renewable and disposable plastics. But to grow and flourish in this new ocean, we need to target specific consumers at different times to capture the opportunity this blue ocean gives us. To establish that positive first impression of water-soluble plastics, the first consumers we're targeting are consumers within the electronic industry. Since electronics can't contact water just like positive plastic, they make the perfect combination. Consumers using computers that have electronics in them with positive plastic find zero difference in ease of use, but feel a sense of accomplishment that they're helping the environment. After initial success in the electronic plastic industry, innovation in the product would lead to solubility that is more controlled. For example, the plastic would dissolve after 1 week instead of after immediate water contact. This would greatly increase the amount of applications possible. At this point, we can expand the use of positive plastic to containers, shopping bags, and toys that rarely contact water to have a bigger environmental impact. When the technology advances enough, we can include water bottles as well by only dissolving the plastic in salt water or at a certain temperature. A prototype is currently being synthesized at a lab. Equipment being used to test includes Fourier transform infrared spectroscopy, thin layer chromatography, and thermogravimetric analysis. Before this project, I also launched a Kickstarter project creating a more durable and environmentally friendly ruler which received funding from many backers from all over the world, including Germany, UK, and Australia. My goal is to reduce the amount of plastic going into the ocean. Creating a convenient and renewable bioplastic that dissolves in water is the perfect solution. This blue ocean is just waiting to be explored, and positive plastic is the first to take advantage of it.